Hello, everyone. Welcome to today's online seminar on Analysis Ready Datasets. As a note, this session is being recorded and you will receive a notification when the webinar recording and the slides are available to you. So I'm Julie Goldman, Research Data Services Librarian at Countway Library at Harvard Medical School, and I offer a lot of these data management trainings. But I'm also available to the Harvard community for consultations on identifying best practices for data management, creating a data management plan, or if you need to find data. The Longwood Medical Area Research Data Management Working Group has a website full of resources and information. And this working group includes many members of the LMA community from the library, information technology, our research cores, and affiliate hospitals. So we suggest that you bookmark this website and reference it as you need. So let's review today's learning objectives. We have quite a bit of content to cover in today's short session. So we'll understand how data management planning can lead to reduced data cleaning. We'll differentiate between messy data and tidy data, and we'll identify principles for or of analysis-ready data sets. So in today's session, we will primarily focus on preparing data for data entry and capturing data in spreadsheets, since spreadsheets are traditionally what we use to capture and create data sets. However, I understand a lot of you may use statistical software or programming languages to work with your data. And the principles for working with a clean data set prior to analysis should be followed regardless of where and how you are working with your data. So to get us started, it is often said that 80% of data analysis is spent on the process of cleaning and preparing the data. So we need to really think about our data sets ahead of time and actually while we are collecting our data. So when working on a research project, you should take some steps to ensure that your data is safe, authentic, and available. And in addition, take steps to ensure that your data is usable. So to be useful to yourself, other researchers, biostatisticians, data sets should facilitate clear and unambiguous communication, be useful by current software applications, provide a traceability between the analysis and source data, be linked to machine readable metadata, and then be analysis ready. So analysis ready data sets have been reasonably collected and reviewed so that the analysis of that data yields a clear, consistent, and error-free result to the greatest extent possible. So in this session, we will cover the following concepts for preparing our analysis ready data sets. And those are creation, validation, standardization, cleaning, and documentation. So first, creating data in spreadsheets. So spreadsheets are these two-dimensional way to store, view, analyze, and alter two-dimensional data. And spreadsheets are widely used software tools for data entry, storage, but then also we can do analysis and visualization within our spreadsheets. So here are the best practices for creating data sets that we will review each of these. So all data should be labeled. You should have unique field names. And when you use, say, Excel, a spreadsheet program, you have to do this yourself. So be sure to put field names at the top of each column. And each experimental subject should have a unique study ID. And be sure to add a study ID to each subject about which you are collecting data. So consider these names of rows. Study IDs must be unique so that rows are not confused with one another. And you should periodically check your subject IDs and ensure that they are in fact unique. And the example data on the slide lacks these unique IDs for each subject. The field names at the top of the file make it clear that the data contains data for 4 subjects from the study baseline, those are A through D, and 3 subjects from the follow-up, E through H. But what is not clear is which subject did not follow up or did not show up for that follow-up. And without knowing that, we don't know whether her MTOP score increased or decreased. So we would add a column to the left, which includes a unique number for each participant in the study so that we are not replicating column or study ID names. All right, so data should be in this rectangular format. So rectangular format means that there are no duplicate values in any single row. When recorded rectangularly, each cell is therefore meaningful. Non-rectangular formats may look like a reasonable way to store data, but the file cannot, maybe cannot be read in that form by a statistical package. It cannot be stored easily. It cannot be used in, say, creating a pivot table. It could not be examined using filters and therefore not easily understood. So you could choose either these examples on the slide to structure your data. The long layout or longitudinally uses a phase variable to delineate the different visits. And then the wide layout uses different field names for baseline and follow-up information, so that phase variable is not needed. So also rows should represent the appropriate unit of analysis. Your columns should represent the unique attributes of the rows. This is also the concept of tidy data, which we will cover under formatting our data. So the first example does not meet this organization. Oops, sorry. So again, this first example does not meet this organization, but the second example has one row representing the units being analyzed, and each column represents one unique attribute being measured. So next, data files should contain the same number of columns in each row. Problems will arise when data are missing in the middle of a row. So in the example, we are missing data in the middle of a row. Data row 4 is missing that follow-up underscore MTOP value. So the subsequent values are shifted over. And to fix this, we would insert a cell with the missing value of what the missing value should be. And then the shift, then all of the other values will shift over to their proper place. And we might also want to add a NA or not applicable here for easy analysis. So data should be atomic within each column. This means discrete data should not be combined into a single column. So first, we see that the columns name, hospital, and site doctor have multiple data points in them. And ideally, we should break these up. So we should break up name into a first and last name columns. And the hospital name should be separated from the city and the address location. And same thing with the site doctor. Those should be 2 separate different data points. So we can use text to column features to split up text contained in a single cell to multiple columns. So we see next that we have done this and the hospital city, it's now its own single column from the hospital name, and we have created a column for the first and last name. All right, so next concept is formatting. And we have already seen a little of this, but let's highlight the tidy data principles. So tidy data specifically has become the standard format for the sciences because it easily allows people to turn a data table into graphs, analysis, and insight. And in practice, our raw data is rarely tidy and it is much harder to work with. So the benefits of tidy data include that the tidy format makes it easier to understand the data and clearly convey the concept of a variable and what type that variable has. Second benefit is consistency. One of the most common challenges that data scientists face is the problem of formatting our messy data sets. So tidy data provides a standard for data entry and format that can be therefore become this consistent across projects. And then third, compatibility. So tidy data has full compatibility with more advanced analysis tools. So remember that spreadsheet programs like Excel may not be compatible with other programs. So by organizing our data in a logical way that can be read easily by a computer, therefore that data is more interoperable. So a tidy data set has this default structure. Each variable forms a column, each observation forms a row, and each data set contains information on only one observational unit of analysis. So each variable is placed in its own column, each observation in its own row, and each value in its own cell. All right, so next principle is validation. And validation helps ensure that data is collected correctly. So data should be actively validated as much as possible throughout the process of your data collection and entry. And this will, reduce the time spent later cleaning your data, explaining your outliers, and accounting for any missing data. And there are a few best practices for validating or reviewing your data sets that we will go through. So program valid ranges for inputting data into fields when applicable. So for example, when entering data, do not allow an age greater than 150 years or allow only numbers to be entered into numeric fields. And you can do this by using formulas in Excel to set data validation to these specific parameters. You should apply data types to fields to prevent automatic formatting. So set up date fields to only accept dates rather than setting them up as free text fields. Again, use data validation in Excel to limit the inputs in specific fields. And the same thing can be applied to fields that may lead to errors in data entry. So for example, if you use a list of options to restrict data entry, the spreadsheet will provide you maybe with a drop-down list of the available items. So instead of multiple team members trying to remember how to spell species names or auto spelling, correct, taking over, you can then select the right option from the list and everything will be standardized moving forward. So next, prevent the entry of leading and or trailing spaces or maybe other characters that may interfere with your data analysis. So you could go back and, after, all your data is entered and use Excel formulas or maybe Open Refine to clean up your data afterwards. But you can also set up your spreadsheet, set up your data collection ahead of time, set up your data entry tables so that these spaces are not allowed And this is the Excel formula that you could use for this data validation. Here we should plan for those other data responses. So this is mostly focused on survey data collection, but you should always prepare for all possible answers. And to encompass all possibilities, ideally just include an other category as an answer and create a text box to maybe capture some free text information from your survey participants. And, you know, when reviewing your answers, if more than 10% of your respondents select this other category, you are probably missing an answer and therefore can go back and modify your survey. And you can review these other texts that your respondents have provided and add those frequently mentioned to your list. So the example question on the slide doesn't include other options such as healthiness of the food, the price or value, or some other option. Also plan for the prefer not to answer category. So sometimes respondents may not want you to collect certain types of information or may not want to provide you with those types of information. So such questions as, you know, income, occupation, finances, personal hygiene, political or religious beliefs are too intrusive and may be rejected by the respondents. So incentives and assurances of confidentiality can, you know, make it easier to obtain private information. While current research does not support that prefer not to answer options, increase data quality or response rates. You know, furthermore, different cultural groups may respond differently. So therefore, you should always include an answer or place to record did not choose to answer or does not know. This will also help avoid your null data and you don't have to address it later or that it will interfere with your data analysis. So next principle is standardization, and this is used to establish consistency. It ensures the data is internally consistent, that the data is the same kind and format for each data element that you are collecting. It also helps minimize data collection and analysis errors and prevents any inconsistencies. And these are the best practices for standardizing your data that we'll review. So use coding schemes harmoniously. If data is coded as no equals 0 and yes equals 1, then all of your yes, no questions should use this same coding scheme. And each categorical variable should have a set of exhausted, mutually exclusive codes. And these codes should be thoroughly documented in your code book or data dictionary. And wherever possible, standard codes should be used. And this facilitates maybe the comparison of results across variables or even across studies. And ideally, data should be reduced to numeric codes whenever possible. This avoids the occurrence of those typing errors in entering literal answers, leading to misinterpretation of two equivalent answers as being different, and above all, greatly facilitates the use of variables in statistical models, as most statistical packages cannot use character values. They really prefer these numerical entries. So standardize your free text into these categorical data. And wherever possible, free text should be standardized into categories. Rather than asking an open-ended question, ask questions with controlled choices, also known as closed questions. So yes, both open-ended and closed questions have these advantages and drawbacks, as shown on the figure on the slide. But notice that, choosing one question type over the other actually involves a trade-off. So although open-ended questions afford this breadth and depth of your reply, responses to these open questions are sometimes difficult to analyze. You have to go into text analysis and use maybe other types of software to analyze those answers. And while closed questions are, on the other hand, easier to analyze, they don't provide a lot of that context or depth on a topic. So you must think critically about which types of questions you will use and how you plan to analyze them. So treat date and time consistently. So date variables are often the cause of many data analytical nightmares. And date variables are often problematic as there is no real uniform standard for date formats. And therefore, it is very important to choose a standard and keep the same date format for each record for all date variables in the project. When working with data files, you'll often require the date to be stored in a specific format. And Excel is a nightmare when handling dates. We'll just put that out front. But you can use it to reformat and change date formats to a specific formula, and then paste those values where you need. So again, choose one date format and employ that standard throughout. And ideally, I suggest using the ISO 8601 standard. That's the year, month, day. This is not how Excel will automatically format your dates, so just beware when working with dates in Excel. All right, cleaning. So before performing analysis of your data, you should review the data set for any inaccuracies, inconsistencies, or sensitive data. And cleaning your data allows you to identify those outliers or errors before you, compile all of your results. So here are the 3 best practices that we will go through. So checking for outliers. Ensure all data elements are in the correct formats and correct ranges. Outliers are infrequent values, far from the normal. Often conversion errors or data entry mistakes must be, those are the things that you must be explained or repaired. And remember back to our validation best practices. So while you can avoid outliers from the start, this may not always be the case. So going back and reviewing the data for outliers may be necessary. And then check for missing data. Ensure there are no data items or records that are missing, creating null elements. And code your missing data appropriately. Again, our best practices from validation can prevent this missing data, but sometimes some retroactive cleaning is needed. And then ensure that your data does not contain any PHI or protected health information. So the Health Insurance Portability and Accountability Act, or HIPAA, privacy rules protects individual medical records and other personal health information. So HIPAA requires that researchers protect the privacy and confidentiality of their patients. So no individually identifiable health information should be included in your data sets. Personal identifiers include private information that subjects expect not to be made public, that are linked to information associated with a unique individual. Direct identifiers such as name, mailing address, phone number, social security number, photographs or date of birth are tied directly to one individual. And then indirect identifiers may include gender, rare disease, place of birth, occupation, income, education, age, those identifiers. If you are working with, HIPAA data or PHI, it's recommended that you use REDCap, which is a data or survey collection platform that can automatically flag personally identifiable data. So there are tools out there to help you work with this sensitive data. All right, and documentation. Lastly, before analyzing or sharing your data, ensure that you have appropriate documentation. Appropriate documentation facilitates, the understanding, the analysis, the sharing, and the reuse of your data. And these are the best practices that we will cover for documenting. So data should be stored with appropriate metadata. And again, metadata is that contextual information required to interpret data and should be clearly defined and tightly integrated with your data. So recall our tidy data. When data is organized in this way, the duplication of information is reduced, and it is easier to subset or summarize the data set to include the variables or observations of interest. So data set A at the top is untidy because it mixes these observational units, species, location, location of the observations, measurements of the individuals. And the units are mixed and listed with the observation. More than one variable is listed. And several formats are used in the same column for dates and geographic coordinates. Whereas data set B on the bottom is an example of a tidy version of the data set A. And this reduces the amount of information that is duplicated in each row. And by having species in a separate table, they can be identified uniquely using the species code. And it makes it easy to add information about the classification of these species. It also allows researchers to edit the taxonomic information independently from the table that holds the measurements about those individuals. And with this example, if the focus of the study for which these data were collected is based upon the size measurements of the individuals, information about the where, when, and what animals were measured is considered that metadata of this data set. You should create and use a data dictionary and README files. So metadata should always accompany a data set wherever it is stored. But the best way to do this may depend on the format of the data. So as we saw previously, some metadata will be included, within the data table or within the data frame. But metadata and information about the data set should also be captured in a data dictionary or README files. So a data dictionary is something that describes the data in a data set and includes the overall description of the data along with more detailed descriptions of each variable. But here is an example of a data set with its accompanying README file. Remember to create a new file with your cleaned or analyzed data. Don't modify the original data set or you will never know where you started. And keep track of the steps you took to clean up your data or your analysis. Track these within your README file. And your README file should be in a plain text file stored in the same folder as that data file. So save your data as machine readable, ideally as an CSV or comma separated values file. Encoding your data keeps your data secure and also saves you storage space. Also storing the data you're going to work with for analyses in Excel, default file format is not a good idea. This proprietary format may not be available in the future. You won't be able to open it. Also, other spreadsheet software may not be able to open files saved in this proprietary format. So storing data in universal, open, and static format will help deal with this problem. So try tab delimited or comma delimited files. CSV files are plain text files where the columns are separated by columns. And the advantage of a CSV file is that we can open and read this CSV using just about any software. It can be easily imported into other formats and environments, such as maybe SQLite and R. So on the slide is an example of a spreadsheet and the same data as a plain text file in the CSV. All right, and lastly, we want to adopt appropriate file naming practices. This wouldn't be a data management webinar if we did not talk about file naming practices. So ideally, you want your file names to accommodate multiple versions of data files. And the basic way is to incorporate versioning information into your file names. So when creating new versions of your files, you should record what changes are being made to the files and give the files a unique name. So you include maybe a version name or version number, excuse me, such as V01 or V02 or V2.1. You could also include information about the status of a file, for example, including draft or final, as long as you don't end up with confusing names like final 2 or final revised, and ensure that you are using final correctly. You could also use dates in your file names as well. So remember to use that ISO 8601 standard for dates. And this works best if the date is listed first within the file name. So saving multiple versions makes it possible to decide at a later time that you may need to revert back to a previous working version. So there you have it. Your data set should now be nicely formatted, validated, standardized, cleaned, and documented, all ready to be analyzed. So let's quickly wrap up with some takeaways on today's webinar. So take some steps to ensure that your data is safe, authentic, available, and usable. Data should be in this analysis ready phase. Analysis ready datasets have been responsibly collected and reviewed so that the analysis of your data yields this clear, consistent, and ever-free result. So you should take some time up front when creating data to focus on two-dimensional data, these tidy data principles, establish some consistency and standards, and record your metadata. And if needed, review and validate and clean your data prior to conducting any data analysis. We have some upcoming webinars, so be sure to register at the link provided on the slide. On Thursday, we will be talking about publishing your hopefully nicely cleaned, analyzed data with your research. So thank you for joining today's webinar. The recording and the slides will be posted on our website. I would appreciate your feedback on today's session, so please fill out the survey at the link provided on the slide.